Hello and welcome to another A-Level Computer Science video with me, Mr Goff, from MrGoff.com. This video will focus on linked lists and stacks. A linked list is a dynamic data structure. This means it can grow and shrink in size. Each item in a linked list consists of data and a pointer to the next item in the list. It uses a heap, which is a collection of memory locations available to the list. When data is added to the list, a memory location is selected from the heap, and the pointer of the previous item in the list is updated to show where the next item can be found. The final value will always have a null pointer. Let's say we wanted to add a new name, Dan, to our list in position 1. In Python, we would say names.insert 1 for the position we wanted to go into, Dan. Rather than having to rearrange all the data items in the list, we simply pull another address from the heap and adjust the pointers so that Bob now points to where Dan is located, and then Dan points on to where Jim is located. When an element is deleted from a linked list, the pointers are once again adjusted, and the memory address is returned to the heap so it can be used in the list again if something else is added. In Python, linked lists are automatically created for you. Whenever you use a list in Python, it is a linked list in the background. This is a form of functional abstraction. That's because the programmer does not need to know how the list structure has been implemented, just what each of the list methods available does. A stack is a LIFO, meaning last in, first out data structure. A good analogy for a stack is the dirty dishes in a restaurant. As dishes are returned from the front of house, they are stacked one on top of the next beside the sink where the dishwasher is hard at work. New dishes from the front of the restaurant can only be added to the top of the stack. Dishes being removed to be washed can also only be taken from the top of the stack. So the last dish that was put onto the stack will be the next dish to be removed and washed. A stack can be implemented using either a static data structure, for example an array, or a dynamic data structure, such as a linked list. As memory is not infinite, either way it will have a maximum size. It will also have a pointer to the top of the stack. A stack has 5 methods. Push is used to add an item to the stack. It adds it to the top of the stack. Pop removes and returns the last element in the stack. Peek returns without removing the last element in the stack. IsEmpty is used to test if the stack is empty, and IsFull is used to test if the stack is already full. There are many uses of stacks in computing. For example, the back button in a web browser. When you browse websites, each site you visit is added to the stack. When you press the back button, the last site is popped off the stack and returned to your browser. Another example is the undo button in a document editor. When you edit a document, each instruction is pushed to the stack. Pressing undo pops the final instruction that had been pushed to the stack and returns the document to its previous state. We've now looked at all the theory of stacks. The best thing to do now is to work with them in practice. So, have a go at trying to build a stack class with attributes for stack, max size and pointer, and methods for pop, push, peek, isEmpty, and isFull. After you've done this, we're going to create a memory game which uses a stack where each turn the computer randomly selects a color from red, blue, green or yellow, which is added to the stack and displayed to the user. The user then has to input the colors in the reverse order they were given. That is, it has to match the colors as they're popped off the stack. The game should end if the player gets one wrong, or if they get the list right when it is at its maximum size. As an extension, you could use peek as a way for players to have a free guess. That brings us to the end of this video on linked lists and stacks. Join me again in the next video when I'll be running through the solution to the problem we've just looked at. Use the resources at MrGoff.com to help you revise computer science, and until next time, it's bye for now.